Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers, subscribers, viewers, and uh, students. Here is another problem in Vitamath 83. There are two problems here. If you want to anticipate the solutions to these problems, you can do so by pausing the video and not looking at the solutions. So that should be the good attitude of my subscribers, viewers, and students for you to prepare yourselves in the more challenging lives in engineering later. So find the area of the shaded region. So this is the shaded region and these are the given. We have two right triangles and because these are transversal angles, they are equal. So we have similar triangles here. And in order for us to analyze this well, let's call that x and this distance as y. And let's rotate the figure. Area is 1/2 of x times y, or 1/2 of xy, y times x. So x as to 15 equals 8 as to y from these two similar triangles. So area, the reason why area is 1/2 of y times x, because if we're going to flip this uh, triangle, the base is imagined to be the y and the height, which is the the perpendicular distance from the other vertex to the base, so which is just extended, is x. So that's why it is 1/2 of xy. And by similar triangles, these two opposite angles are equal. So opposite of this angle here is x, the adjacent side is 15, so x over 15, while in this right triangle, the opposite is 8 and adjacent side is x. So that's why xy is 15 times 8 or 120. So that's the explanation here. That's y, the base, and this is the height, that's 90 degrees. So that's why the area is 1/2 of yx or 1/2 xy. And we set up this by similar triangles from these two. So xy is 120, therefore substitute here, the area is 1/2 of 120, and it is equal to 60 square meters. For the second part, show that the triangle ALR is an isosceles right triangle with right angle at A and on the directrix of the parabola, and L and R are ends of the latus rectum. So right triangle at A on the directrix of the parabola, and L and R are ends of the latus rectum. Also determine the area between the triangle and the parabola in terms of the length of the latus rectum L sub R. So I want you to experience this. This may be important, or this should be important in your future endeavors. So this is the parabola open upward, and these are the ends of the latus rectum. So therefore, the intersection with the y-axis, which happens to be the axis of the parabola, is the focus supposedly. And these are the tangents at the ends of the latus rectum. So first, let's show that the triangle ALR is an isosceles right triangle. That means we have to prove that the angle measured here is 90 degrees. So we proved that the slope of the tangent at the ends of the latus rectum would be 1, 1, or they make 45 degrees with the horizontal or vertical. So x squared equals latus rectum times y. This is the standard equation of a parabola that is open upward. you're already you're supposed to, this is Vitamath 83, so it is assumed that you are already through with calculus or you are an engineering graduate. So it's no longer a problem. If you do not know this, then you have to recall or search that this is the standard equation of a parabola that is open upward. You just wait for the completeness of my uh, playlist in Engineers in Progress, where I discuss curves there, is particularly conic sections. Parabola is one of them. So therefore, that's the end of the latus rectum. Because of symmetry, this, if we denote the length of the latus rectum as LR, then this is just half of LR. So that's LR over 2, then the y coordinate is, just call it YR. This is also LR over 2, so in particular L is negative LR over 2 comma YR. So LR over 2 square is equal to, we substitute into this equation here, the value of x is LR over 2 equals LR YR. So from there we can solve YR, which is LR over 4. LR over 4. So from calculus, we differentiate this to x equals LR y prime. Y prime is the slope of the tangent at R or at L. So x is LR over 2 at R. So 2 times LR over 2 equals LR times y prime. We can cancel 2 and we can cancel LR. So y prime is 1. That means the slope is 1 in AR. Y prime is 1 and the corresponding angle it makes with the horizontal is 45. So the angle it makes with the vertical is also 45 degrees. Then at L, the only difference is the slope is negative 1. So that means if I call that theta, that's also theta by symmetry. So that's 90 because this is 45 degrees. This is also 45 degrees. Just set y prime LR equals negative. The x coordinate at L is negative LR over 2. So theta equals 45 degrees. So that's LR over 2. That's also, this is LR over 4 from vertex to focus. Distance from vertex to directrix is also LR over 4. To make it LR over 2, LR over 2, so that makes that angle 45 degrees. So thus ALR is an isosceles right triangle because the vertex angle at A is 90 degrees. So A is on the directrix because by definition of parabola, it is the path generated by a point moving so that its distance from a fixed point, which is the focus, is equal to its distance from the fixed line, which is known the directrix. So one position of the point, moving point, would be here. So its distance from the directrix is LR over 4. Distance from focus is LR over 4 also. So if the point is at the ends of the latus rectum, the distance, for example, of the moving point from the focus fixed point there is LR over 2. Its distance from the fixed line directrix is also LR over 2, LR over 4 plus LR over 4. So that's it for this video.